Hi, my name is Leela and I'm with Engineering4All, and I'm here today to introduce the very first workshop of our online workshop series. So Engineering4All is a nonprofit from downtown San Jose, and before the COVID-19 crisis, we were working with 3 different elementary schools in that area to provide engineering workshops and clubs, and because of the quarantine and all of that, we've had to move our operation online. So starting from today, we're going to be doing our workshops, which teach engineering to elementary schoolers through different platforms like YouTube and on our website, and they'll all be done over video. Today's workshop topic is going to be civil engineering. A civil engineer is an engineer who designs and maintains roads, bridges, dams, and other structures. If you have seen construction happening around your neighborhood, or if you've seen people working on fixing roads, then the people who are leading those projects, who are helping design those buildings that are being constructed, or who are helping figure out how to fix those roads, are probably civil engineers. So if you're interested in construction or stuff like that, being a civil engineer is a great job choice. So today we're going to be focusing on a project that centers around civil engineering. And as we get into that topic, we're going to have to look at a couple of big concepts. So the big engineering concepts that we're going to tackle are going to be center of gravity, geometry, and resourcefulness, which are all 3 different topics that all engineers use. So the very first concept is called center of mass. Center of mass can look like this. And it's basically when in an object, when you put your finger underneath an object and you're able to balance it by holding it at one specific point, that point is called the center of gravity. That means that the entire system, or the object itself that you're trying to balance, is at balance at that point, meaning that all of the things on one side are equal in mass to all of the other objects on the other side. So it's kind of like a seesaw. When you put 2 people of equal weights on either side of the seesaw and you ask them to hold the seesaw so it's flat, that's when a system is in balance, and that's when you found center of mass. The second concept that we're going to be exploring in this project is geometry. Geometry matters for civil engineers especially, because you will need to decide what are the different kinds of shapes you want to use in the thing that you are creating. How geometry can look to a civil engineer can be this. Can you see the different shapes in the different designs of the buildings? So next, try and find the different shapes in these drawings of buildings that I've put up. The last concept that's going to be important for everybody as we're doing this process is resourcefulness. So resourcefulness is using the different things around you to finish your task. So remember to ask your parents or any other adult around you if you can use the different things around your house to complete this project. Now that we've gone over all the concepts we need to know to complete this project, let's get into what our activity for today is. So today's activity is going to be building a bridge with different household items. Just like civil engineers create bridges that are hundreds of feet long in the real world, today we're going to be creating smaller bridges out of the different materials we can find around our house. So the different things that you're going to need are materials for the bridge itself. You can use something sturdy like popsicle sticks, toothpicks, or even index cards that you can bend to make the structure of your bridge. You're going to need a binding agent, so something sticky like hot glue, regular glue, or tape to hold the different materials for your bridge together. And then lastly, you're going to need something that'll go on the bridge itself. So these are things that you'll be putting on your bridge to test how much that your bridge can hold. So these can be something small that'll fit on your bridge. I'll be using pennies, but you could use different materials like beans or even pencils if you can balance them on your bridge. Pause the video here and grab the different materials you need to complete this activity. Okay, now that you have all of your things, let's go over what this activity really wants us to do. It says, with your materials, build a bridge suspended in between two books or tables, and make sure that it's something that can maintain its shape and not break when something is put on top of it. So basically what they're asking is create a bridge out of the different materials, such as the popsicle sticks or toothpicks or index cards that you've collected, and make sure that it holds the materials that you are planning to put on top of it. As we do this activity, we're going to follow the different steps of the engineering design process. As I go through the engineering design process, I will walk through what each of the steps mean. So the very first step of the engineering design process is brainstorming. After that, we'll have prototyping. Next, we're going to have design, then we're going to have build, and last but not least, we're going to have test and rebuild. And these are all steps that we're going to go through as engineers. As we start building this bridge, we're going to start with the very first step of the engineering design process, brainstorming. So why do we brainstorm? We brainstorm to get all of our ideas out on the table and to make a large list to select one idea from. And how do you brainstorm? You brainstorm by creating pros and cons lists and drawing simple sketches to see if your ideas make sense on paper. When I brainstormed for creating my bridge, I considered all of the different materials I had to work with, and I wrote down the different positives and negatives of using them in a design of a bridge. I also created different sketches. These sketches allowed me to see how I could use the different materials to build my bridge. You can do similar things with the materials that you have at home. You can create a list of the different ways you can use your materials to make a bridge, and you can draw out how those materials will go together. The next step of the design process is prototyping. You can prototype by picking 2 or 3 of the ideas that you brainstormed, and then creating small-scale models of them to prove that those ideas work. The 2 or 3 ideas that you pick from your brainstorming that can be prototyped are going to be 2 or 3 of the ideas that you think are most likely to work well. When I prototyped to help create my bridge, I picked the ideas that I had for making a bridge out of toothpicks and making a bridge out of popsicle sticks. Similarly, you can pick 2 or 3 of the ideas from your list that you think is most likely to work, and you can use more flimsy materials than the kinds that you would use for the final bridge to just test to see if your sketches and your different designs make sense. After you're done creating the 2 models from your prototyping phase, you're going to test those 2 models to see which one works better. The model that works better is going to be the model that you will continue designing and developing because it is the most likely to work well for your final bridge design. After you have this model, you're going to move on to the 3rd step of the design process, which is design. So the design step of the process is about creating a final drawing of your product, which in our case is the bridge, so you can get ready to build it. As you can see, I created a design with popsicle sticks because I found that my popsicle stick model works the best. And I made a drawing from the top view and the side view to show people how it should be. Once you're done with your design, it becomes easy to move on to the next step of the design process, which is building. During the building step, you have to create the final model of your bridge based on the design that you created from the earlier step. For example, I created a bridge made out of popsicle sticks, tape, and glue, and I did that all based on the drawing that I made from the earlier step. You can do a similar thing with the different materials that you have at home based on the drawing that you created. Once you're done building your bridge, you have one last step before you're finally finished with the design process, and that step is testing and redesigning. You can test your bridge by taking the objects that you had initially decided that you wanted to test the sturdiness of your bridge with and setting a goal for your bridge. For me, I set a goal for my bridge to hold 15 pennies because pennies were the objects that I wanted to test the sturdiness of my bridge with. For you, that number might be different. You may want to test with 20 beans or 5 pencils, but set that goal. And then put the pennies or whatever object that you have on your bridge and check to see if it can hold up to your goal weight. If your bridge can't hold up to your goal, then you may want to consider redesigning your bridge. For me, my bridge didn't hold 15 pennies, so I had to go back and remake a part of my bridge. For you, when you're redesigning, you may want to remake certain parts of your bridge, you may want to add more glue, or you may want to add support structures to make sure that your bridge is able to hold your goal weight. Once your bridge is able to hold the goal amount of objects, that means that you are done with the design process and you have a fully functioning. Now that we're done creating our bridge, let's revisit the 3 engineering concepts that we started with. The first engineering concept that we explored was center of mass. All of you were able to explore the idea of center of mass when you tested your different bridge designs. Through testing, you were able to determine which one of your designs had the most stable center of mass. The second engineering concept that all of you guys were able to explore through this project was resourcefulness. Every single one of you was resourceful as you were able to look around your house and find different items and objects and able to incorporate that into your bridge's design. The third engineering concept that everybody worked through was geometry. As you guys were designing your different bridges, you guys used many different shapes in your sketches and in your prototypes, which allowed you to explore which shapes worked better and which shapes worked worse for your designs. I hope everybody loved learning about civil engineering from our workshop today. Remember, this is our first workshop of our weekly online workshop series, so remember to tune in every Tuesday to learn about a new engineering concept. Keep up with what Engineering4All is doing around the community by following us on Instagram at ENGG4All and visiting our website www.enggforall.org.